Uh, So analysis of IDSC. So guys, can you see a double slit plane like this? Can you see the two slits S1 and S2? Guys, can you see this two slits S1 and S2? Let us say the separation between these two is D. Okay. And let's say you have a screen which is at a distance capital D. So guys, can you see over here? There are two slits S1 and S2, and there is this thing, a screen which is at a distance of capital D. Suppose guys, if you are incidenting a plane wave front, guys, can you see a plane wave front in front of these two slits? So basically, what will happen when this two slits S1 and S2 will be illuminated with the same source? Will they be having any phase difference, or is there any initial phase difference before forming the pattern? No, right? Here there is no path difference or phase difference over here because it's the same wavefront, right? Let's talk about at this point. Can you see this point, which is exactly midway between S1 and S2? So let's say there is a point O exactly midway between S1 and S2 on the screen. Yes or no? You understood the point where exactly it is located, guys? Can you see S1 S2 के बीच का जो distance it was D. So basically D by 2 and D by 2. Is it clear? Guys, is it clear?
Yes,
Yeah.
sir.
हाँ. Now tell me this particular thing. If I have a wave which goes from S1 to point O, so I have a wave which goes from S1 to point O, and I have another wave. Can you see, guys, the waves from both S1, both the sources, S1 and S2? This is the wave. This is wave 1, and this is our wave 2. Where are they superposing, guys? They are superposing at point O, right? Yes or no?
Yes, sir.
If I calculate what is the path difference between them, what will be the path difference? Can you see path difference will be the difference in the path? So can I say S1O is the path traveled by wave 1 minus S2O is basically the path traveled by the second wave, right? Yes or no? Now, can you see this particular distance S1O and S2O? They both are equal, right? Here S1O is also equals to under root of D square plus D by 2 whole square, and S2O is also the same thing by Pythagoras theorem, right? Ayana, guys. So can you see S1O and S2O will be equal? If S1O and S2O will be equal, then what will be the path difference? So here in this case, the path difference becomes 0.
Zero.
And if the path difference becomes 0, what kind of interference will happen?
Destructive interference.
Constructive interference will happen. Destructive थोड़ी होता है, constructive होता है, right? So here a constructive interference will take place. आपको याद है ना कि whenever delta x is equals to 0, lambda, 2 lambda, and so on, constructive interference, and whenever delta x is equals to lambda by 2, 3 lambda by 2, 5 lambda by 2, and so on, then it will be a destructive interference, right? So can you see, guys, this one? Guys, hello? Can you see this part? This case, delta x equals to 0 is basically formed at point O. Is it clear?
Yes, sir.
So a constructive interference will form over here, and a bright fringe will be formed at the center. Okay? And a bright fringe will form at the center. This bright fringe is called as, guys, this bright fringe is called as central bright.
Maxima.
Ha, central bright or central maxima. Is it clear? Central bright or central maxima. This is what it is called. Any doubt in this part? Acha, shall I write central maxima over here? So, someone may guys, what will be the intensity at point of? The resultant intensity will become 4 times of I naught. Is it clear? Guys, is it clear?
Yes.
Check. So, what will happen at the center that we have discussed? Okay? So, all this analysis was only for point O. So, this is at point. Okay? The second case is, let's say, at any general point P. Why am I drawing this? So, guys, the second case is basically where at any general point. So, guys, can you see a screen over here? Everyone is able to see a screen which is placed perpendicular, in the same exactly plane, parallel to the slit plane, right? Guys, can you see the screen exactly parallel to the slit plane? Again, the same case. I am incidenting a plane wavefront over here. So when I incident a plane wavefront, again S1 and S2 are in the same phase. They act as coherent. Do you remember all that stuff we already told, right? Yes or no, guys? What is this distance, guys? Distance between S1 and S2. What is this distance? This distance is small d. And let's say this is basically where point O is located. Exactly midway. Now, what we are doing, we are assuming a point P on the screen, which is at a distance y. So basically, what is y? Y is basically the distance from the central maximum. Understood this particular thing, guys? What is y? Y is basically the distance from the central maxima. D is basically what? Small d is basically the distance between the slits. Capital D is basically what? What is capital D?
Distance of slits from screen.
distance between double slit plane and screen, or basically the distance between the slits on the screen. So ये सब अपने को पता है. Is it clear? Now see guys, what will happen? What will happen? One wave will go from where to where? One wave will go from S1 to point P. Yes or no? Will this will be the wave 1, and there will be another wave which will be going from S2 to point P. So can you see guys, two waves? This is your wave 1 and this is your wave 2. Can anyone tell me what will be the path difference in this case? What will be the path difference? Guys, can anyone tell me what will be the path difference? Will the path
S2P
difference?
minus S1P.
Very good. S2P minus S1P, because यहाँ पे clearly दिख रहा है the wave 2 has to travel a greater distance to reach point P, and the wave from wave 1 has to travel less distance. So the difference S2P will be greater than S1P, right? So if I want what is the path difference between them, then this will be the path difference, right? Yes or no? Yes or no, guys?
Yes, sir.
हाँ.
Yes.
अब इसके बाद देखिए, please remember in YDSC the slit separation. What do you mean by slit separation? Small d is way less as compared to distance between slits and screen. So basically d. So here, what exactly am I saying? This small d is basically way smaller as compared to capital D. Is it clear? Guys, is it clear?
Yes, sir.
If this is the case, then can you see from here? I can draw two triangles like this. I can, I'm deriving this whole thing. Mm, I'm drawing this whole thing, again. So this was your S1, this was your S2, this distance was small d, and basically this distance was capital D. Now assume that this angle is theta. Guys, can you see what is this theta angle? This theta is basically called as the angular position of a point P, or whatever bright fringe, dark fringe will be forming over there. The theta is basically called as what? Angular position, right? Yes or no? Hello? So guys,
Yes,
can you
sir.
see from here, if I assume that angle to be theta, this was basically y. So can you see over here, there is a, this triangle, this point was O. So can you see there is midpoint is, let's say, M. So in triangle MOP, M is basically the midpoint of S1, S2. O is basically the point where the central bright is there, and P is the general point, right? So in triangle MOP, can I say y divided by d is basically equal to tan theta? Yes or no? Can I say this? Guys, can I say this? I can say this, right? yes or
Yes,
no?
sir.
हाँ. अब now एक और चीज देखो. If I drop a perpendicular from S1 over here, let's say this point is N, है ना? So let's say we drop a perpendicular from S1 over S2P at point N. So guys, can you see again one more triangle has been formed now? Can anyone see this triangle? ये वाला तो सबको दिख गया होगा, right? M O P. This triangle, I think it's clearly visible to everyone, right? Guys, this triangle is visible, right? Can you see this triangle?
Yes, sir.
है ना? थोड़ा सा गौर से देखना है ना. I am trying to make it a little bit big. है ना? So this is S1, this is S2, this is point N, and this is the perpendicular which you have drawn. This distance is basically D. Now, tell me this particular thing, guys. What is if I have taken D much less than capital D? That implies this point S1 will be lying over here somewhere, and this point S2 will be lying somewhere over here, very close to each other, right? S1 and S2 will be lying very close to each other. Yes or no? Since D is much less than D, that implies S1 and S2 lie very close to point P and each other as well. Point M and each other as well, right? M will be somewhere over here. Guys, इतना clear है क्या? S1 and S2 were lying very close to point P, point M. If they lie very close to point M, then the perpendicular S1N, the perpendicular which you have drawn, S1N, is very small. If it is very small, then can I say, sir, S1 से लेकर जो P तक का distance, I'm not able to write. Okay, एक second. My OneNote has crashed. Just give me 2 minutes. S1N is very small. Guys, देखते रहना approximation. See, I know it's more of a approximation. So the perpendicular S1 is very small. That implies the distance from S1 to P and the distance from N to P can be taken as same. So basically, I am assuming that these 2 points, they lie very close to each other. So what will happen? The distance from S1P or the distance from NP, it will be almost the same, right? This triangle which is looking big, it will be very small. It will be like this. Are you getting my point, guys? So this triangle will be very small. इतना clear है? So S1P is approximately equal to NP. Now एक थोड़ा सा गौर से देखना guys. Suppose if this angle is theta, this angle is 90 degree. Can anyone tell me what will be this angle? This angle पे जाने दो. ये वाला angle कितना होगा? What will be this angle? Both are going to point P because they are, distance capital D is very far away. So, it will look like parallel lines. You have assumed this angle to be theta. So this angle will also become theta, right? Yes or no? थोड़ा assumption समझ में आ रहा है guys? Since we have assumed this thing, and that is why it will look like a very small triangle. For that small triangle, this point P will be far away. So if it will be far away, then it will look like parallel lines will be going, right? So if you have assumed this angle which was coming from M as theta, then this angle will also be theta. If this angle is theta, this is 90 minus theta, and if this is 90 minus theta, this angle is understood. Understood, guys?
Yes, sir.
If you have assumed that point P is far away, then you will get parallel lines, almost parallel lines. This angle you have assumed theta, so this angle will also become theta. If this is theta, then this is 90 minus theta, and this is 90 minus theta, so this is theta. So guys, we all can see there is one more triangle which was formed over here. S1, S2, N perpendicular, and this distance is small. Now, guys, do you remember what was the path difference? What was the path difference? Do you remember? Path difference was S2P minus S1P. So path difference was S2P minus S1P. So can you say I can write it as S2P minus NP? And what is S2P minus NP? NP, can you see, guys? S2P minus NP is basically equals to this S2N, right? So this is equals to S2N. So basically this is your path difference. And if this is your path difference, this angle was theta. You can form one more equation using trigonometry. Guys, using trigonometry, what will be that equation? Can you see this angle के सामने वाला is basically what?
Sin theta.
Sin theta. So using trigo, sin theta is equals to delta x upon. So guys, can you see at the end you are getting two different results. Guys, can you see two different results? So in Young's double slit experiment, this is the assumption which we need to take always. The distance between the slit and the screen is basically way greater as compared to the slit separation, right? Guys, just give me 1 minute, है ना? Let me make one call. एक ये लिख लो. Y by uh, एक second. Y by D is equals to tan theta, and एक और relation is delta x by D is equals to sin theta. इतना लिख लो. Once you're done with this, then we'll write the next assumption, है ना? मतलब स्पेशल केस, इसका भी स्पेशल केस. There is one more derivation which your school people have given. So we'll, if you want, we can do that as well. If you want, वरना कोई बात. अरे ऐड मत चले यार बार बार. करो गाइस, एक सेकंड. कॉल. Chalo guys, done. Guys, are you done? Guys, are you done?
Yes, sir.
So basically, this is the final result which we need to remember. In y Young's double slit experiment, y by capital T is basically tan theta and delta x by d is equal to sine theta. Special case, if theta is very small, basically matlab theta is tending to 0, right? If theta is very small, then we can use approximation. Can you see in that particular case, sine theta will be approximately equal to tan theta will be approximately equal to theta, but in radians, right? Yes or no? So basically, what will happen if theta is very small? This and this will become equal. If this and that will become equal, then can I write delta x by d is equals to y by capital D? Yes or no? Or can I write y is equals to delta x by d into capital D? So basically, this is how you will find out the position. At least remember this is equals to theta है ना, तो angular position निकालनी हो तो like this. So what is y? Y is basically what? The distance from central maxima. So if you want to find out what is the distance from central maxima, you can just put the value of part difference and automatically your answer will come. Right? Is this clear? Is this clear, guys? Is this clear?
Yes, sir.
Yes, sir.
So now let's see the points for. ये बहुत ज़्यादा important है by the way, but please remember this is only special case when theta is very small. This question is on general case. When theta is big, है ना? When theta is big, you can apply this. But when theta is small, you can apply directly this. Is it clear? Don't worry, I'll give you a question. You'll understand it from there. So it's okay. Now, case one. If I say for a bright fringe, for nth और ऐसा नहीं nth की बाद में करेंगे, for a bright fringe at point P. If you want a bright fringe shall form at point P, then can I say this particular thing? For a bright fringe at point P, what shall be the value of delta x? The delta x can be 0, it can be lambda, it can be 2 lambda, it can be so on, right? Yes or no?
Yes, sir.
And generalize, if I write, so delta x is equals to 2 lambda, oh sorry, n lambda. किसी को याद है ये लिखा था? Where what was n? N was starting from 0, 1, 2, 3 and so on. Yes or no? So we generalized it like this. Delta x was equals to n lambda. Let me put it over here. If I put it over here, y equals to uh, n lambda into d by d. Yes or no? So n lambda into d by d. This is for nth bright position. But here n will start from 0, n1, n2 and so on. Position of nth bright fringe from central maximum. Sir, why did you say nth bright fringe? Can you see over here? When you will put n की value 0, if you will put n equals to 0, the position will also become 0, right? That implies the this thing is basically forming at point only, right? Yes or no, guys? At point O, this is basically what your central maxima, right? Yes or no? Hi, Anna, guys. When you will put n
Yes.
equals to 1 over here, so what will be the position of the first bright? The position of the first bright will be lambda d upon capital D. So basically at a distance of how much distance? This distance shall be lambda d by d, capital D, lambda into capital D upon small d, na? You will get your first bright. So that is what we have written. Here we'll get our first bright or first maximum. If I'll put n equals to 2, then what will happen? Guys, if I put n equals to 2, then what will happen? I'll get the second bright, lambda twice of lambda d by d. This is the position of the second bright. Are you getting my point, guys? So basically, you'll put different values of n. For example, if they have said seventh bright, so seventh bright may you'll just put 7 over here. That's it. Anna, is it clear? Is it clear, guys? Hello, guys. Is it clear? See, whatever pattern
Yes,
is
sir.
forming above the point O, exactly same will form below point O as well, right? जैसा pattern ऊपर बन रहा है, exactly same pattern will go downwards as well. Why? Because can you see when I told you that this can be plus or minus lambda, plus or minus 2 lambda. Are you getting my point? So that minus sign will basically indicate what? The same pattern goes downwards as well. Is it clear, guys? ये समझ में आ गया? This is the path difference. This is the position of nth bright. Now case number 2 for a dark fringe. Yes, can anyone tell me what will be the path difference for a dark fringe? किसको याद है? Delta x was equals to lambda by 2, 3 lambda by 2, 5 lambda by 2, and so on. So I generalize this as delta x equals to 2n minus 1 times of lambda by 2. याद है किसी को? I generalized it like this, but where n is starting from 1, 2, 3, 4, and so on. Right? I have not started with 0. If I would have started with 0, this would have been plus 1. Sir, what's the reason behind it? Can you see over here? If I put this path difference in nth dark, I want now. So basically in place of delta x, I'll put this thing. So it will become 2n minus 1 by lambda by 2. This is your path difference multiplied by d by d, right? Yes or no? Delta x d by d, यही था. So can you see over here, if I write it together, can I write it like this? 2n minus 1 by 2 lambda d by d. This is the position of nth dark fringe. Up here you will not put n equals to 0 because n equals to 0 is put where? In central bright. Is there any central dark in this case? सेंटर पे डार्क हो सकती है क्या? अच्छा, कैन यू टेल मी दिस कि इज देयर अ पॉसिबिलिटी ऑफ a dark forming at the center? Although I will come to that question little bit later, but abhi for now, can you see any possibility of at this particular point you will get a dark fringe? Guys, can you see any possibility of a dark forming at the center at this moment of time? अभी मैंने पढ़ा नहीं आ गया ना, अभी जेई मेन से एडवांस नहीं गया, अभी नॉर्मल स्कूल लेवल चीजें चल रही है. So here in this case, there is no possibility like that. है ना? So anyways, so if I want what is the position of the first dark, so for first dark, you'll put n equals to 1 over here. If you'll put n equals to 1 over here, this is basically lambda by 2, right? So this will be lambda d by 2d. The position of first dark will be lambda d by 2d. Similarly, second dark will be formed at 3 lambda d by 2d. Please remember, this is basically I'm doing n equals to 1, n equals to 2, n equals to 3. So basically in place of n, I'm putting this thing. Is this clear, guys? In place of n, I'm just writing. If I want third dark, then y 3d is equals to 5 lambda d by 2d. So this is how you'll find out the position of these particular thing. Sir, one important point to notice in this particular case is, okay, suppose if this is your screen, if suppose this is your screen, this is, let's say, the point M, and let's say this point is S1 and this point is S2, है ना? So at this point always delta x will be 0, and what will be formed over here? The central bright will be formed, right? Then just after the central bright, you will, you'll get what? After, at a distance of how much? Lambda d by 2d, you will get our first dark on both the sides, not necessarily only on one side, on both of the sides at the same distance, lambda d by 2d. 1 second, sorry, my bad. This is, here it will be minus lambda by 2. You will get our first dark. Guys, are you understanding the pattern? From central bright, you have the first dark, and then exactly at the same distance away, at this much distance, this is basically lambda d by capital D. Can you see this? The where the first dark was forming, the first bright, can you see? It's formed at twice the distance. Just try to notice the pattern from here only. So are you getting my point, guys? Central bright, then first dark, then first bright, then second dark, then so on. Are you getting my point, guys? सबको समझ में आ गया ये कैसा हुआ? If you want, you can check their distances and just plot them over here. So central bright, then first dark, then first bright, then second dark, then second bright, and then third dark, and so on. Understood the pattern, guys? You understood the pattern, how
Yes.
exactly it is forming? Please write their respective path differences as well. ये पूरा पैटर्न बना लो. No, it's very necessary. Make it. अच्छा, give me 2 minutes. I'll be back. बहुत ज़्यादा छोटा हो गया. Please make it, guys. Give me 2 minutes. I'll be back. Yes, guys, done. Guys, are you done? Two things to note. First point is a pattern of alternate dark and bright fringes is found. So, guys, can you see alternate bright and dark fringes is found, right? For a incident, for a plane incident wavefront, for a plane incident wavefront at the center, always a bright fringe will be found. वेरी इंपॉर्टेंट है ना, सिर्फ प्लेन वेव फ्रंट के लिए होता है. सो इज फर्स्ट एंड सेकंड पॉइंट क्लियर guys? First and second point is clear. There is one more thing, but wo I'll teach it as a new heading only. Can you see the distance between, what is the distance between central bright and first bright? What is the distance between central bright and first bright? It is lambda d by d, right? The distance between central bright and first bright, it is lambda d by d. So this distance is also lambda d by d. What about the distance between first bright and this thing? Can you see this distance from here? It will be 3 by 2 times of lambda d by d. So can you see a pattern, guys? 0 0.51, 1.52, 0, 0 0.51, 2.52. Are you getting my point, guys? सबको समझ में आ रहा है थोड़ा थोड़ा? Guys, are you understanding this with me? This is 3 by 2 lambda
Yes,
d
sir.
by d. This is basically 1.5, right? So 0.51, 1.52, and so on. So can you see over here, the distance between the fringes is uniform? Can you see the third point is basically the distance between two consecutive bright fringe and two consecutive dark fringe is uniform. This distance is called as the fringe width. So please write the new heading. fringe width in young double slit textile. And do you remember fringe width? I already explained to you. Guys, do you remember fringe width? I told you that this is basically fringe width. I'll denote it by beta. Beta. This point is basically the maximum intensity point in the fringe. Is basically what? The this thing. The bright. And this is where the dark is formed. The dark. Right? So what was fringe width? Please write down the definition. The distance between two consecutive dark fringe or two consecutive bright fringe is called as fringe width. ठीक है? It is denoted. I denoted using the letter beta, denoted by beta. Okay.
Yeah.
So always remember, for beta, what will you do? You'll just do y n plus 1 the next bright or next dark में से कभी मैं previous वाले की position if I subtract the distances. So basically, can you see, if from second dark, if I subtract the distance of first dark, I'll get what is the fringe width. This distance is basically called as the fringe width. This distance is also called as the fringe width. This distance is also called as the fringe width. Are you getting my point, guys? Fringe width क्या होती है? Understood?
Yeah.
So basically, yn plus 1 minus yn. So if I suppose if I have for bright fringe, if I what is the position of nth and n plus 1th bright? N plus 1th bright will be given by, sir, we know in the case of we know this is equals to what? N lambda d by d. So in place of n I'll write n plus 1. So n plus 1 lambda d by d minus, if I want yn, so will be n lambda d by d. So lambda d by d will be common, n plus 1 minus 1, n plus 1 minus n. So can you see? Lambda d by d. This is for a bright fringe. Same thing you can do it for dark fringe as well. For a dark fringe, we know what is the position of nth dark. Guys, what is the position of nth dark? 2n minus 1 by 2 into lambda d by d. So again, you'll do the same thing. In place of n, you'll place n plus 1. So twice of n plus 1 minus 1 by 2 into lambda by d by d minus 2n minus 1 by 2 lambda d by d. And which when you will solve, eventually it will give you what? Lambda d by d only. You can do this solving part as a homework. I don't mind. But can you see over here, guys? The distance between the two consecutive fringes, it is coming to be constant, right? Is this clear?
Yeah.
So
Yes,
that
sir.
is what is basically a fringe width. Is it clear?
Yep.
So here also the fringe width is basically this. Here also the fringe width is basically this. So kindly note the distance between the fringes is same for both bright and dark. and fringe width is constant. Can you see, guys, fringe width depends only on three factors. What are those three factors? First is the wavelength. So suppose, guys, if you dip this whole setup in a particular, let's say, water. If you try to do YDSA in water, then what will happen in the case of this thing? Are you aware of this particular relation? देखो, ये याद है आपको? mu2 by mu1 is equals to v1 by v2. And guys, can you see v1 v2 can be written as f into lambda and f into lambda? Can you see velocity and lambda, they are directly proportional to each other, because on changing the medium the frequency doesn't change but the wavelength changes, right? So can you see the same relation goes for lambda 1 and lambda 2? So basically if you dip it in a particular medium, then basically you will be decreasing the wavelength, right? Because you will be increasing the mu, right? Here also, can you see from here, mu is inversely proportional to lambda, right or wrong? If mu is inversely proportional to lambda, then on decreasing, sorry, on increasing mu, lambda decreases. So basically, kabhi suppose karo, if the whole setup is repeated in water, then basically I have increased the refractive index of that medium, right? So basically वहाँ पर lambda decrease हो जाएगा, and if lambda decreases, then beta also decreases. So can we see fringe width will also decrease? Is it clear?
Yeah. Yes, sir.
So suppose if this is the question somewhere, you give if a whole setup of YDSC is dipped in water, एग्जाम्पल के रूप में दे रहा हूँ, है ना? So basically what will happen when you dip it in water, you are increasing the refractive index from 1 to 1.33, right? So lambda will decrease accordingly and fringe width will also decrease. So first point, I guess the first point is pretty much clear, wavelength. The second point is basically point number B, D. D is basically the distance between the slit plane and the screen. So if on increasing D, if you increase the distance between the screen and the slit plane, then basically what will be doing? You will be increasing beta. Is this clear, guys?
Yes, sir.
Acha, we know the fringe width will increase, but intensity of the fringes will decrease, because we know this particular thing, na? Guys, do we know this particular thing? Intensities, they depend upon the distance, right? So basically the distance, if will increase, then the intensity of the fringes which will be formed, it will decrease. So the second point is basically, the third point is basically slit separation. On increasing the slit separation, on increasing D, beta decreases. So basically what, can you see, guys, all this thing is coming from this particular thing, lambda d by d, inversely proportional to small. Can you see? Yes or no? In spite of writing like
Yeah.
this, I'll write it like this. Beta is directly proportional to lambda, beta is directly proportional to d, and beta is inversely proportional to small d. Is it clear? So basically what will happen, if you decrease the separation between the two slits, on decreasing the separation between the two slits, ये जो pattern है, guys, hello, if I decrease this distance, then this separation between the two, it increases, है ना? ये याद रखना, उल्टा होता है यहाँ पे. On bringing the slits closer, enlarge the fringe width, or basically increase the distance between the fringes. So guys, I think I made my point pretty much clear. Yes or no?
Yes, sir.
ठीक. Fringe width between comes out to be same. Fringe width is independent. हाँ, एक और important चीज about fringe width. Second point is done. Have you noted down till this much? Everyone?
No. Yep.
अच्छा guys, एक second. Now, if you have not noted down, यहाँ पे एक point और लिख देना. Let's calculate also. No, what is that fringe width? So initially the fringe width was basically lambda d by d. But now what will happen? If you dip it into a medium, lambda will change to lambda dash will change. Lambda will decrease, right, by a factor of the relative refractive index of 2 with respect to 1. याद है सबको? अरे, from here only. Can you see this? Yes or no? Are you getting my point, guys?
Yeah.
Okay, lambda dash. So suppose uh, if it is performed in water, then beta initial one in air, it was beta, and then in water, it let's say becomes beta dash. So it becomes lambda dash d by d. So it will become lambda by mu into d by d. And can you see this lambda d by d is nothing but beta? So from here, beta dash is equals to beta upon this. Is it clear? So ये calculate भी कर ही लो. Acha, one more thing. If I ask directly, if I perform YDSC with red light and if I perform YDSC with violet light, tell me in which case will you get more fringe width? Normal oral question, you know. In red light, will the fringe width be more, or in violet light, will the fringe width be more?
In red light, right?
Red light. Because
Because
red
red
की
color
wavelength
wavelength.
is more, so beta will also be
Okay.
more. Clear है? अरे clear है?
Yep.
One
Yes, sir.
last point which I need to write. The third point. The fringe width is independent of the order of fringes. So whether you calculate the fringe width between the third and the second, or whether you calculate the fringe width between the 16th or the 17th, the fringe width is going to be the same, right?
Yeah.
So that is why I said order of the fringes is basically what? Order of fringes is nothing but n. The n thing, you know, guys, do you remember n? Here n, this n is called as the order of the fringe. The fringe width is independent of the order of fringes. Basically n के independent होता है ना? That is, you can say the fringes are equally spaced. Is it clear, guys?
Yes, sir.
Acha. If someone says ki find out the intensity in Young's double slit experiment, if someone tells you to find out intensity of the pattern or intensity of the fringe at any general point y. If someone asks you to find out the intensity of, at any general point, so first thing first, step one is to calculate. Everything will be done with the help of path difference over here. If you can calculate path difference, then from the path difference calculate the phase difference, and phase difference we know how to calculate from path difference, right? Phase difference is basically delta x by lambda into 2 pi. And 5 upon 2 pi is delta x by lambda, right? So I can rearrange this thing. Always remember this relation, है ना? याद रखना, ये relation will be most helpful to you. Delta x upon lambda is 5 upon 2 pi. So if you want to convert each other, can you see when completed one wavelength, one complete 2 pi phase? Are you getting my point? है ना? तो ऐसे करके you can relate. Once you found out the phase, step 3, we know what is the intensity का formula. The intensity at point P will be basically 4 times of I naught into cos square 5 by 2. ये formula हमने derive किया है, if you remember. Have we derived this? Guys,
For
have we
path
derived?
difference?
हाँ, नहीं, the intensity at point P in interference when we were teaching you.
Yeah.
जब intensities were equal, I1 equals to I2 equals to I naught.
Yeah.
So basically here, since the sources are same intensity, so basically what will happen, intensity at point P will be this, or you can use this thing, 4 I naught into cos square. Phi की जगह पे I'll write this thing in place
We
of
did it
pi.
for standing waves, right?
हाँ?
Standing waves के लिए किया था ना ये हमने last year.
Standing waves के अबे अभी भी किया है, ये रहा which lecture, second lecture में भी. नहीं, third lecture where we discuss the intensity part.
Yeah, I remember.
ये रहा.
Yeah.
So the same thing applying over here. अच्छा, delta x will be equals to what? एक formula from Young's double slit experiment which we calculated already, y d by d. Oh, उल्टा कर दिया, sorry. You remember y is equals to delta x capital D into small d, ऐसा करके लिखते थे हम. So I can write delta x is basically this, right? If I can write this, I can put it over here, and ultimately when I'll put the final formula over here, it will look like pi small d into y upon lambda into. So ये भी एक फॉर्मूला बन सकता है if you want to मतलब relate things. Is it clear, guys? Young's double slit experiment. Any doubt?
No, sir.
Question करें? I've got more questions. So in the next class also we'll do some more questions, and then we'll leave some space. And some नहीं मतलब बहुत ज़्यादा space will leave for the advanced portion of wave optics. मतलब approximately 15 pages. 15 नहीं ज़्यादा हो जाएगा. Approximately 10 pages. In the next class, I'll be done with your Young's double slit experiment, and at least mains level will be done. And mains level, this thing, need level will be done. Advanced level, we are leaving that. There are different ways in which you can tweak, the Young's double slit experiment. So we'll study all that. So I'll make you leave 10 pages for that. But anyways, let's start with the questions now. Question is, guys, first question. A YDSC setup is immersed in water. Refractive index 4/3. If the slit separation, they have given it in words, but I'm not writing the whole thing in words. If the slit separation is 1 millimeter, and distance between the slits and the screen is 1.33 meters. Incident light on slits have a wavelength of 6300 angstrom. Then find the fringe width on the screen. है ना? So basically incident light जो थी वो कितना था? 63,000. Oh, sorry, 6300 angstrom. So basically, as soon as it comes into water, what will happen? Its value for lambda will change, and lambda will become lambda by mu, right? And can you see it is going from air to water? It is going from air to water. So the refractive index of water with respect to air is basically 4 by 3. Medium 2 with respect to medium 1. So this will become 6300 angstrom divided by 1.33, or basically our 4 by 3. This is our lambda dash. And now we know what is beta dash. Beta dash is equals to lambda dash into d by d. So 63,000 by 6300 by 1.33, and please remember, don't leave it like angstrom and all, है ना? पूरा पूरा करना है. You need to solve everything. D is 1.33 meters, so let it be 1.33. उसके बाद small d is 1 millimeter, तो 1 into 10 to the power minus 3 meters. So you need to change the units and all. Is it clear? When finally you will solve it, it will be 6.3 into 10 to the power minus 4 millimeter. Oh, sorry, minus 4 meters. Or you can write it as 0.63 millimeters. That's the answer. ठीक है guys, हो जाएगा. Guys, shall I give you next? Easy tha. This question was easy, directly based on concept. Next question. In a YDSC setup, find the distance between the two slits that result in the formation of third minimum for. अच्छा, by the way, 4200 angstrom, which light? Red or? तुमको ये याद है क्या? Does anyone remember what is the wavelength of red light and what is the wavelength of violet light? Okay, ये याद रखना बेटा हमेशा. Wavelength of, if you can't remember the last term, तो ये याद रखना कि wavelength of violet light is approximately 4000 and this is approximately 8000. Is it clear? If you can't remember it exact data, then no problem. So anyways, the lambda is given to you 4200 angstrom. I'll write the name as well so that kabhi in case. Violet light at an angle 30 degree. Take small d is much less than cap. So you want basically what? क्वेश्चन को बहुत आराम से पढ़ के, see, wave optics is very easy. Till the time you are, considering everything, you are able to visualize everything, then, it will become very easy. Wait, sorry. Otherwise, it can become a nightmare as well. So, anyways, ये अपना screen. This is our central maxima at point P, and they are saying, sir, these are my slits S1, S2, and at an angle 30 degree. At point P, I should have a third dark. Yes or no? And they are asking what shall be the value of D, right? Yes or no?
Yes, sir.
So basically, guys, do you remember this triangle? ये याद रख लेना triangle. If you can't remember the triangle, remember the formulas. If you can't remember the formulas, remember the triangle at least. This was delta x and this was d. एक triangle ये था and दूसरा triangle क्या था? This was y, this was d, this was theta. है ना? If you can't remember the triangles, can't remember the formulas, remember the triangles. वो याद नहीं तो formula याद कर लेना. Out of one, do any one thing. And now can you see over here? For third dark, this angle theta is given to me. Theta is basically 30 degree. I want to find out d, and there is one relation between delta x by d is equals to sine theta, right? So if I can find out delta x somehow, then automatically my d will be calculated, right? So we know this particular thing, guys. For third dark, what is the value of delta x? Do you remember delta x for any dark was basically lambda by 2, then 3 lambda by 2, then 5 lambda by 2, and so on. So basically, will this be your third dark?
Yes, sir.
So for delta x equals to 5 lambda by 2, you'll get your third dark. So you'll write it as 5 into lambda by 2 divided by sine of 30 is equals to d, right? Yes or no? So from here d is equals to 5 into lambda. ये हो जाएगा 1/2, ये हो जाएगा 2, 2 से 2 cancel, this will become 5 lambda. And what is 5 lambda? Lambda, I think it was given to you, 4200 angstrom, right? So from here d will be equals to 5 times of 4200 angstrom, and which will be 21,000 angstrom. So this will be 2.1 into 10 to the power 4 into 10 to the power minus 10 meters. So are you guys understanding conversion? I'm doing conversion, है ना इसको मैं. So 2.1 into 10 to the power minus 6 meters. So basically this should be the separation between the slits, so that the third minima falls over there. Is it clear?
Yes, sir.
Yes, sir.
चलो एक और similar type of question, shall I give it for homework? Guys,
हाँ.
one similar type of question, I'm giving it for homework. Can you see a double slit plane? And in front of this double slit plane there is a screen. So in this YDSC setup, S1 and S2 are given to you. Lambda, the light which you are using, I'm not writing the whole statement, hai na? Guys, the statement is something like this. In a YDSC setup, a light of wavelength 6000 angstrom is used. What shall be the separation between the slit? What shall be the separation between slits so that a third bright forms in front of one of the slits? So basically they are asking you what is the value of small d, for which just in front of one of the slits there should be third bright. Understood? I'll
हाँ
begin with this thing. Let's say the distance between the two slits is d, and baki ka you people will think, है ना? So this question is a homework for you. The answer I'll give you. The answer is 6 millimeters. Is it clear?
yes sir.
ठीक है. अच्छा हाँ, D is also given to you. The distance between the slit plane and the screen, D is given to be कितना दिया है? 10 meters. हो जाएगा? The answer is 6 millimeters. Anyways, next. I think I'll be done with all the questions today only. No, still some or two questions or more will be doing in the next class. In a YDSC setup, guys, please understand the language very carefully. Na? In a YDSC setup, slits are illuminated by एक second. Okay, okay. By two sources one having wavelength 4000 angstrom and another wavelength is unknown. So basically what did he do? From a source illuminated by a source, एक दो source नहीं करते, illuminated by a source producing two wavelengths. So basically in a YDSC setup, slits are illuminated by a source which is producing two different kinds of wavelength. One wavelength is basically 4000 angstrom and another wavelength is unknown. समझ में आया? Now see the question. It is observed that in the fourth dark fringe of unknown wavelength, no, sorry, of known wavelength, in the fourth dark fringe of the known wavelength, the second bright of unknown wavelength is coinciding. Now what will be your question? Obviously find the unknown wavelength. How will you do these type of questions? जहाँ पे सर wavelength, there are two different lights used and basically what is happening, they are coinciding. What do you mean by coinciding? Hello, what do you mean by coinciding? Coinciding basically means both the fourth dark fringe of the known wavelength and the second bright of unknown wavelength, they are forming at the same place, right? That is what is meant by coinciding, right? Yes or no? Guys, yes or no?
Yes, sir.
Fourth dark of noon and second bright of unknown are coinciding. That implies the position of fourth dark of noon is equal to the position of second bright of unknown, right? Yes or no? Arey, yes or no?
हाँ
So basically for known wavelength, let us say it is lambda, and for unknown wavelength it is, let's say, lambda dash. Is it clear? So can I write fourth dark? So do you remember for dark fringe we know the formula is ना, पहले मेरे को formula एक बार बता दो. For y nth dark 2n minus 1 by 2 into lambda d by d, right? Is this for nth dark? And for nth bright it is n lambda d by d. Yes or no? Setup same है दोनों का. Is the setup same? Guys, is the setup same? So this value and this value is going to be the same. If the setup is same, d and d will be same in both the cases. हाँ है ना? So twice of 4 minus 1 by 2 into lambda d by capital D is equals to 2 into lambda dash into d by d. I think it's solvable now. So this will become 7. This will become 4 because this 2 will come over here and multiply with this 2 into lambda is equals to lambda dash. Ayana. And what was lambda? Lambda was given 4000 angstrom. So 7 by 4 into 4000 will be basically 7000 angstrom. So these type of questions are very important. And a school point of view से तो बहुत ज़्यादा. In the next class, we'll do some 2-3 more questions. We'll talk about the maximum order of the fringes, and then we'll leave the 10 pages which I told you. In advanced portion there is a lot of things are there, guys. Or 10 भी नहीं, मतलब let's leave more only. Let's leave approximately 12. ठीक है?
Okay.
Sir,
हाँ जी. बोले?
sir, why is capital D and small d equal?
Why? Because the same setup is being used, no beta? Can you say it was the same source only but having two different wavelengths? And
Oh,
say
okay.
the setup is also same, no? The distance, is the distance between the slit varying for both the cases? It's the same.
No.
The distance between the slits and distance between the slit and screen is the same. So capital D and small d is same. So that's why दोनों तरफ cancel हो गया.
Okay, sir.
ठीक है. So in the next class I'll be done with this particular thing, and interference will be done, and we'll start with diffraction. ठीक है. Diffraction is also very small. It's just like a one lecture setup. देखेंगे, मतलब at least in the next 2 lectures I'll be done with diffraction, and then polarization also 2 lectures, and within this or the next week I'll be done with wave optics as well. ठीक है. Once I'll be done with wave optics, I'll be starting modern physics. We'll start with atoms and nuclei, or maybe photoelectric effect. Chaliye guys, thank you very much.